Lesson number 7 on differentiation, increasing and decreasing curves. Now what we're looking for here is for any given curve, I would like to be able to tell for any given point whether the curve is going up, increasing, stationary, or decreasing, going down. I don't want to have to draw the curve, I want to be able to tell this from the equation of the curve. So what we're going to do is when we're given a point on the curve, in order to be able to tell if it's increasing, decreasing or stationary, we're going to be calculating the gradient of the tangent at that point. So if I picked a point over here, the gradient of that tangent would be positive, and that means the curve is increasing. If I look at one of the areas where the curve is decreasing, going downwards, and I put a tangent there, I can see at that point the gradient would be negative. It's going in the opposite direction. So all I need to do here is differentiate to get an expression for the gradient, substitute in the value of the point that I'm trying to find, work out the gradient. If the gradient's positive, I know the curve is increasing. If it's negative, I know that it's decreasing. As always, I'm going to need to remember to justify my conclusion by comparing it to what I know. So if m is greater than 0, the curve is increasing. If m is less than 0, the curve is decreasing. In our first example, we're asked to determine whether the curve is increasing or decreasing when x is equal to 10. And the curve that we're given is y equals 4x squared plus 2 over the square root of x. Now the first thing we're going to want to do is differentiate this so that we can work out the gradient at the point where x equals 10. I can't differentiate it in the current form. I'm going to need to move that x from the bottom of the fraction. So it's going to be 2x to the power of negative because it was on the bottom of the fraction, and a half because it was a square root. Now I'm in a situation where I can differentiate. So dy by dx is equal to multiply by the power and reduce the power by 1, 8x. 2 times negative a half is negative 1, and 1 less than negative a half is negative 3 halves. And I know I'm going to be substituting into this, so I'm going to tidy up the expression. So 8x minus the negative there tells me it's underneath the fraction. The 3 over 2 tells me it's x cubed square rooted. So when x equals 10, the gradient is equal to 8 times 10, take away 1 over the square root of 10 cubed. And that can be simplified to 80 minus 1 over 10 root 10. If you're not sure of how that surd worked, check the red bubble. As a decimal, that is 79.97 approximately. So we've calculated the gradient, and now I need to say that the gradient is greater than 0. Therefore, the curve is increasing. So we differentiated, we substituted in the x coordinate to our derivative, making sure that once we differentiated we tidied it up so it was easier to substitute in. The value that we got out for our gradient, we compared it to 0, and because it was bigger than 0 we knew the curve was increasing. Okay, the second example, which is on page 13. We're given the equation y equals 1/3 of x cubed plus x squared plus x minus 4, and we're asked to show that this curve is never decreasing. Now I'm going to be using the same skills that I used before, but I need a little bit of extra thinking in here. If it's never decreasing, that means the gradient can never be less than 0. So I'm trying to think about what sort of expressions will never give me a negative number as an answer. I'm going to go ahead and differentiate, but in my mind I'm going to be thinking a little bit about what I expect the answer to be. Now there's no preparation required here, I can go right ahead and differentiate this as it is. So dy by dx, 3 times a third is 1, so that's x squared, plus 2x, plus 1. Now this, I'm thinking, oh, how do I know if that's always going to be positive? In this current form, it's not that easy to see. I'm going to go ahead and factorise. And I see now that I get x plus 1 times x plus 1, which I could also say is x plus 1 squared. If I have any expression squared, the answer can never be a negative number, because even a negative number squared becomes positive. So the smallest value this could ever be is 0. What I need to do is find an appropriate way of communicating that to show that I've understood what's happened. So I'm going to start by saying this expression will always be greater than or equal to 0, because it could be 0 if what's inside the brackets was 0. Therefore, the gradient is always greater than or equal to 0. And if the gradient is always greater than or equal to 0, that means the curve is never decreasing. Just be careful here, it's tempting to say that the curve is always increasing, but it's not. Most of the time it will be increasing, but if it is actually equal to 0, it would be stationary. We're going to have a lesson on stationary points next. Okay, just to check you've understood the main points today. If you're given a point on a curve, how will you know if the curve is increasing at that point? If the gradient of a tangent at that point is positive, what does that tell you about the curve at that same point? Okay, we're now at a point where we can work on exercise 6L. Question 1 is unit level questions, which you might want to practice now. 2 to 7 are level C, and 8 and 9 are AB questions.